In this video, we're going to factor a quadratic that has a leading coefficient that's greater than 1. And what I mean by that is this first number, our leading term right here that you see, it has a 15 for its coefficient. So normally it just says x squared, for instance, like that. But this one has a 15. So whenever that number is greater than 1, there's a real easy process you can use in order to find its factors. So the first thing we're going to do, and I'm going to write over here just step 1. We're going to multiply a to c. So when I say a, I want you to remember that when you're dealing with a quadratic, this first value is your a value, and then this is x squared plus your b value plus your c value. So respectively, 15 is your a value, negative 17 would be your b value, and 4 would be your c value. So we're going to multiply a to c. So what I like to do to show that I'm doing this is I usually circle that a value, and then I just draw a little line going over to c, and I circle it. So I'm going to multiply those together, and I'm going to draw an arrow because we're going to write that answer to it once we multiply it down here. Now I am going to use my calculator, right? I recommend always use your calculator to make sure you don't mess up with the simple multiplication. So I got 15 times 4, and it gives me 60. So I'm going to write a 60 right here. So now that I got 60 there, and I've done this multiplication, I can ignore the 15 from now on. And I'm just going to rewrite these first few terms. In other words, I'm going to bring down my x squared, and I'm going to bring down my b value, negative 17, and it's x. And since it was a positive 15 times a positive 4, that was a positive 60. So now I have a new quadratic, right? Or it looks to be a new quadratic, and this is much easier to work with. Notice my coefficient is 1, right? There's an invisible 1 in front of that leading term, x squared. And I'm going to treat this like any other, and from this point, I want to go to step 2. Which step 2 is I'm going to find the factors of 60. So step 2, find factors of c. And when I say c, I mean the new c value, which is 60. So the way we do that is we're going to draw a number tree. So let me go ahead and draw a number tree real quick. It's just an easy way to organize it. So that's my c value is 60. And I'm going to write all my factors. Now I have trouble memorizing my multiplication. I've always been that way. I know some of it, but not all of it. And so what I like to do when I'm finding my factors is I start with 1. And I ask myself, how many times can 1 go into 60? And we want numbers that can go in evenly, right? Because if they're a factor, they'll go into that value evenly. And 1 can go into 60 times. So that's one factor. And then I go, well, what about 2? 2's after 1. So how many times can 2 go into 60? And 2 can go into 60 30 times. And then I just continue this process. The next number is 3. So I say, well, how many times can 3 go into 60? And 3 can go into 60 20 times. Now, if you're unsure about this, right, and like I am sometimes because of the multiplication, just go ahead and use your calculator to divide the next number into 60 and see if it'll work. For instance, 60 divided by 4, and it gives me 15. So I know that 4 and 15 are factors of 60. And then I'll try 5 because 5 comes next. 60 divided by 5, and it gives me 12. So 5 and 12 are factors. Now what I want you to notice is that as I'm finding these factors for 60, notice that we're getting closer and closer to the same number on each side. In other words, they're decreasing on the right side and they're increasing on the left side. So the only numbers we have left to check at this moment are 6, 7, 8, 9, 10, 11. So I'm going to go ahead and try 6 next. 60 divided by 6 gives me 10. 6 and 10. And then I'm going to do my next number. I'm going to see, can 60 be divided by 7? And notice that I got a decimal value. So the answer is no. 7 will not go into 60, so it's not a factor. Well, after 7 comes 8. So I'm going to do 60 divided by 8. And it doesn't work. I get a decimal as well. We'll only have one number left before I hit 10. And 10 is already written down, so there's no point in checking 10. But I do need to check 9. So 60 divided by 9. And notice I get a decimal strain again. It doesn't work. And 10 is already here. And from there, you could continue to go, but you don't need to. Because once you reach the number on the right side, you've already got those factors, right? Because from this point, it's just 10, 12, 15, 20, 30, and 60. Now, these are all the factors of 60. In other words, these are all the sets of numbers that you can multiply to get 60. And so what we have to do is now go to step 3 and see what two numbers can we combine to get 17. So I'm going to go ahead and write step 3 right here. Step 3. Find the factors which add to give you B. So we're just looking at the ones that add to give us B. Now the quick way that I do this is I just start with the very top one, and I go, if I add 1 plus 60, it gives me 61. And then I look at my B value, and I say, well, my B value is 17. So 61 is way too high. And then I go, well, what about if I did 60 minus 1? Well, that would give me 59. And that's still way too high. It doesn't match 17. So I cross it out. There's no way that I can get the value of 17 from adding a 1 to a 60 or subtracting a 1 from a 60. And now try this next one. 2 plus 30 is 32. 30 minus 2 is 28. Both of those numbers are too high and don't match 17. So I go to the next one. 3 plus 20 is 23. And 20 minus 3 is 17. So this is a possibility. So I'm going to put a dot by it. I could also look at 4 and 15. 4 plus 15 is going to give me 19. And 15 minus 4 gives me 11. So it's not going to be that. And then I have 5 and 12. 5 plus 12 gives me 17. And 12 minus 5 gives me 7. Now, if I add these together, I do get 17. So I'm going to put a dot by it, because I can get a 17 out of a 5 and a 12. And then 6 and 10 gives me 16. Or if I do 10 minus 6, it gives me 4. So now, notice I have two possibilities. I can either get a 17 out of the 3 and the 20, or I can get a 17 out of the 5 and the 12. Now, I'm not sure which one it is, but remember there's a rule. Not only do they have to add to give you the B value, right, which is negative 17, they have to multiply to give you the C value, which is 60. So I'm going to go ahead and write step 4 on here. So I'm going to move it up just a little bit. Step 4. Check numbers to see if they multiply and I'm going to move something up just for a moment to give you C. Now what I mean by that, you might be going, well, Mr. H, we know they multiply to give me my C value because they give me 60. But what I want you to do is pay careful attention to the sign. They have to multiply to give you a positive 60, but they have to combine to give you a negative 17. So let me get my calculator, and we're going to test these numbers. There's only so many combinations of positive and negative numbers that you can try, but I'm going to give you an example. If I did negative 3 plus 20, so negative 3 plus 20. In other words, I'm making a 3 negative and I have the 20 positive. That gives me a positive 17. So it's not going to be that one because your B value, remember, is equal to negative 17. We want to get a negative 17, and that's a positive. But I could do positive 3 plus negative 20, and that gives me a negative 17. So now that I know I can get a negative 17 with a positive 3 and a negative 20, I now need to multiply those same values with their sign and see, does it give me a positive 60? Because remember, our C value is a positive 60. So if I do 3 times negative 20, notice it gives me negative 60. So in this case, we know that 3 and 20, even though we can get a negative 17 from it, we cannot change the sign on one of them to get the negative 17 and at the same time make it multiply to give us positive 60. So that only leaves me with one set of numbers left, the 5 and the 17. So in order to get a negative 17, my 5 has to be negative, and my 12 has to be negative. Notice negative 5 plus negative 12 gives me negative 17. And if I were to multiply those same values, negative 5 times negative 12, they also give me a positive 60. So therefore, these are the correct numbers to use. And I'm going to put a sign by them. My 5 has to be negative, and my 12 has to be negative. So from this point, we figured out which two numbers to use. We figured out the signs that they need to be in order to multiply to give me positive 60 and combine to give me a negative 17. And now we're going to go ahead and write them out as this quadratic's factors. So I'm going to write them out like this. I'm going to have two binomials, and both of them are going to have an x. And then we're going to go ahead and do the first one, the smallest value, which is negative 5, and this largest value, right, the 12. Now we are going to make it negative, so typically that's actually smaller than negative 5, speaking if we're looking at it from a perspective of a number line. So we have x minus 5 and x minus 12. Now we're not done yet. All we did was get to step 4, and we found two numbers that multiplied to give us positive 60 and two numbers that combined to give us negative 17. But remember, in the very beginning in step 1, we multiply this a value to this c value. So that leaves us with one more step, and we're going to call that step 5. So I'm going to write right here, step 5. Divide a from the factors. So we're going to divide a. Now remember, a in the beginning we multiplied by a, right? That 15. Now I'm going to go over here to these factors, and I'm going to divide this value, for instance negative 5, by 15. And I'll also divide this other one by the a value of 15. So what we want to do at this point, we want to make sure that none of these fractions can be simplified, because if they can, it will affect the next step if we don't simplify it. So I'm going to go ahead and get my calculator real quick, and I'm going to see, can anything be simplified? A good way to check that is to use your alpha y equals function and then hit enter, and it gives you a fraction bar. And just type the fraction in and see what happens. So for instance, on this one, I have 5 over 15. And notice that gives me 1/3. So I'm actually going to rewrite this factor right here as x minus 1 over 3. Now we're going to do something with that 3 in just a minute. But right now, we're just trying to make sure that everything is simplified. Alright, and we're going to do the next one now. So we're going to do this. We know we're going to have an x. And I'm going to do 12 over 15. So I'm going to do alpha y equals enter, and 12 over 15. And notice it changes it to 4 over 5. So this would be negative 4 over 5. So now that we divided this out and we simplified both of these, we're going to go ahead and continue with step 5, because not only are we dividing a from those factors, but then, so I'm going to put and then move the denominator in front of x. So let me show you what I mean by that. Since we have a 3 as our denominator here, we're simply going to take that 3 and put it in front of the x. So this one becomes 3x minus 1. And then we'll take this 5 right here and move that in front of that x, so that this one becomes 5x minus 4. And now we have our two factors. Now what I will tell you, and in this video we didn't see it because both of these left us, we were able to simplify it, but it left us a denominator on both of these values. But in some cases it will go into it evenly, and if it goes into it evenly, there's no denominator left to go ahead and put in front of the x, other than technically a 1, right? So sometimes if it goes in evenly, you do not have to move any numbers in front of the x. And I'll show you an example of that like that on another problem. But one like this, when you have these two left over, just move them in front of the x, and these are the factors. And you could multiply these back out, you could FOIL these, and see that they'll give you this original equation that we see here.